Hello, this time we're looking at two exponent challenge questions, and they're challenge questions because they use so many of the rules that we've learned. So in our first challenge question, I noticed that we have all of these negatives, and I know that the negative exponent rule is telling me that each of these is in the wrong part of the fraction. So since every single item has a negative, we literally are going to flip this entire fraction to move everything to the right place. So x to the negative 8 moves up top and becomes positive. Y to the negative 15 moves up top and becomes positive 15. What was on the top, x to the negative 5, moves down and becomes positive. Y to the negative 9 moves down and becomes positive. And so we've got all of them moved around and positive at this point. Now that the exponents are positive, we're looking at doing subtraction because it is division. So in this first one, 8 subtract 5 would be 3. And the second one, 15 subtract 9 would be 6. And we've done what looked like a really intimidating problem, just doing one rule at a time. So we're going to try our second problem. This one looks even more intimidating because it has parentheses in it. It has some negatives, but not all. So when I look at this, I know from order of operations that I want to deal with parentheses first. And so I see that there is an exponent outside the parentheses. I see this exponent inside. I don't really see this exponent, so I'm going to write it out because this is really y to the first. And so thinking about my exponent rules, when I have something in parentheses to a power, I want to multiply, almost like a distributive property. So 4 times 2 would give me x to the 8th power. 4 times 1 would give me y to the 4th power. And I still have here an x to the negative 5 and a y to the 3rd power. So looking to work with my denominator, again I have exponents inside and outside the parentheses, and as we reviewed above, we're going to multiply them. So 3 times 2, I would get x to the 6th power, and 7 times 2, y to the 14th power. Now, I have this negative, and there are two different ways to deal with this, and there's not a right and a wrong. It's just two different ways to deal with it. So one way to deal with this negative would be to move it to the bottom of the fraction, because a negative exponent tells me that just this term is misplaced. The other way to deal with it is that I have two different x terms on the top of my fraction, and when I am multiplying, I add exponents. So I'm going to do that second choice. So I have 8 plus a negative 5, which gives me x to the 3rd. I have y to the 4th and y to the 3rd, so together that would give me y to the 7th power, because again, adding the exponents. And so in the denominator, I have x to the 6th, and I have y to the 14th. So from this point, I'm trying to do division. As we talked about up here, division has us subtract the exponents, so I'm going to use that option first. So if I have 3 subtract 6, I would have x to the negative 3. And if I have 7 subtract 14, I have y to the negative 7. Okay? I've done everything well so far, but I'm not there because when I give an answer, I always have to have positive exponents. So I have to make this a fraction. These negatives mean that they're in the wrong part of a fraction. I don't really see the fraction here, but anytime that I have a whole number, I could put it over 1. So then I really am flipping the fraction because they're both negative. So I have x to the 3rd down here, and I have y to the 7th down here. And so I have my answer. Now I want to take us and look at a second approach. So going a different way, I'm going to end up with the exact same answer. I know that multiplication and division cancel each other out. So when I look at the x's here, I recognize that x to the 3rd is literally 3 different x's in the numerator of this fraction. and x to the sixth is 6 different x's in the denominator of this fraction. Yes, how about 6? So, since multiplication and division cancel each other, I see this first one cancels, second one cancels, third one cancels, and down here I have 3 that are left. So equals 1 over x to the third. 3 x's are left in the denominator. Now I can do the same idea with the y's. I don't actually have to write them all out. There are 7 on top. There are 14 on the bottom. I can look at those numbers and recognize that 7 would cancel and 7 would be left. The remaining y's, the ones that did not cancel, would be in the denominator because that's where there was more to start out with. And so my y to the 7th would be in the denominator. So this top approach is using the rules exactly as they're written. We subtracted the exponents, taking top minus bottom, got this, used the negatives to put these in the right location. The second approach down here is using our understanding that multiplication and division are inverses. And so 3 of the x's canceled, 7 of the y's canceled. There were more in the denominator to begin with, so the remaining ones are in the denominator. When you're looking at an exponent challenge problem, you want to just work one step at a time. In this problem, we started with the parentheses based on order of operations. We simplified by adding exponents on like basis in the numerator, and then we have 2 options to simplify to get to our final answer.